If you can see my regression Excel, just say yes or type yes for me. All right, okay. So this is a Brukutu data set. Oh. This is a Brukutu data set that you have. And what we are going to be doing is to take this data set from Excel to R. This is something we are used to already, and we know the command that does that. So highlight everything, Control E to highlight, Control C to copy, and then go to your R. Go to your R. We're going to put this data in R. And then once you get to R, you run the data with the command gen. Okay, that's what I've just done for mine. If you want to see the top part of the data, type head into bracket, then the name of the data, which in this case is gen. And then you run, it will give you just the top part of the data. And I'm using the categorical variables data. Now we did a simple regression. If you can remember, this was a simple regression that we did. Okay, this was a simple regression. We showed all of these results. That's what you see down there. We even plotted the simple regression line. So we've done some incredible things. There you go. So that's a simple regression line. What we want to do today is the multiple regression, which we have done in Excel, but we want to do it in R. So the simple regression was gen simple. We're able to interpret the P. Now, I'm going to just run the multiple regression. How do you do multiple regression in R? Well, it's a very simple thing, but before we do that, okay, yeah, let's just go straight to the point. Okay. Before we do that though, I want to do two variable regression. Now, please follow me here because what I'm about to do is interesting. Now, sometimes a simple regression is just a one surface graph, 1D. 1D, 1D, okay, or let's say 2D. So you have the Y, you have the X, and then you draw the line. You have the Y, you have the X, you draw the line. That's what we've just done. What we are now going to do is to do a 2D, okay, a 2D. And the 2D, before we can do the 2D, there's something we have to do. It is getting slower and slower, I don't know. All right. So I'm going to do a 2D before we go to the 3D. I'm going to do a two variable case. And please, I'm talking about independent variables, two independent variable case. To do that, you need to install this package, which is known as library RGL. The package is known as RGL. Whose microphone is on? Salifu, please always mute yourself so that you don't interrupt us, unless you have a question. So click on packages. You see, when you are doing your own regression, you'll be doing some of these things. When I give you the regression assignment, I'll expect you to run some of these things. So I'm doing it with you so that you don't get lost that day. Okay. All right. So you look for RGL, click install if you have a good internet. And then you type RGL, Romeo, Gallon, Lima. Okay. And then install it. If you have it already, by using the command library RGL, it will pop. RGL. So I'm trying to search for mine to see whether I have it. Okay. I just type RGL. Apparently, I'm not getting it. So you can go and do library RGL to see whether it's there. But it appears it's not there. So I'm going to install mine. RGL. And then you click install. Depending on the speed of your internet, you should get it running. And then there's another package called car. I think this car, we already have it. So that one too, you have to install if you don't have car, C-A-L, C-A-R, car. Okay. So install RGL and then car. All right, ladies and gentlemen, I want to believe that you've been able to do that. So let's run RGL and then car using the library RGL. And I just did that. I've been told that all of them are fine. So this is a command. In my case, I have it at command number 30. That's all you need. Okay, we're going to generate some beautiful 3D scatterplot. And I'm going to do this thing with the variables quantity demanded. Okay, I'm going to do it with quantity demanded of GenBitters. I'm also going to do it with price and then with complement price, 3 variables. Okay. So just type the word scatter, scatter. If you have done the previous one, scatter 3D. Type scatter 3D, and then you write your dependent variable, which in this case is capital Q. Write your dependent variable, which is capital Q. Write your tilde symbol, remember your tilde sign. Then the price, which is capital P, plus the complement price, which is capital C. I'm typing all of them as I go. You bring a comma, then type color, C-O-L equal to, and then for the color, bring a double apostrophe, and you can choose any color. I want to choose green. Bring a comma, and then the name of the data. The name of the data here is data equal to Gen. That is it. So we are going to enter, run it, and then we are going to see some beautiful surface. Remember, when you have dependent and independent variable, you're going to be dealing with a line. But when you have 2 independent variables, you deal with a cuboid or a surface. And then when you have 3 or more, that one you can't draw it. Okay, so you have to use a table. So we're going to do one where you can draw it. So I'm going to run this. Okay, let's run and see. It is coming. There you go. Okay. It pops out. As you can see in mine, it has popped out. So you can see the 3D surface there. You can hold it and then turn it around. Okay. So you can see that I'm holding and dragging it. If you hold and you drag and you hold, you will see that it's no longer representing a line, but then it's representing a surface. And the data points are actually plotted there. Okay. So you can see that this is a surface plot showing the quantity demanded, which is Q there. It is also showing the complement price. It is showing the price of the gen, and it is showing this beautiful 3D. I just hope that you can see it. So this is a way to indicate a 3D regression surface plot. I can make it bigger by this, and then I can click and then be showing all the surfaces. So regression line is when you're dealing with 2 variables, dependent and independent. But a surface plot like this is when the independent variables are 2 in this case. And again, when you look at the price, the relationship between the complement price and the kill, as I look at it right now, it is showing a negative relationship. Okay, if you want to look at the relationship between quantity, okay, so complement price and quantity is showing a negative relationship. But let's look at price and then complement price. Okay, if I look at price and complement price like this, it's not showing much. Okay, yes, yeah, Sumani, what's the question? Sumani, what's the question? Oh, the graph is not sure. Sumani, your hand is up. I don't know whether you have a question. So this is a graph. Oh, okay, hold on.
Doc, can you hear me?
Yeah, go ahead.
Can you hear me? I'm saying that, okay, so it has now shown. Yeah, it just came. Originally, it wasn't shown at all.
So this is a surface plot, and you can see the data points are all showing there. Now, some of the data points are below the line, or in this case, the surface. So you can see that the data points that are below, do you see that it also has drawn the residuals? You see those that are below, the residuals are, the residual lines are there. And whether it is below or above, the color of the residual also changes. The color of the residual changes. So you can see, if I turn it this way, some are below the surface, which means that the residuals are indicative of a negative residual. And then you can have a positive residual. Okay, sure. It's a very beautiful way of trying to show the 3D Scatterplot. All right, I'm sure you get it. One day when you are doing your work, one day you tell somebody that, look, I know how to do it. That's why I've done it. Okay, so you can show it to somebody that you know how to do 3D Scatterplot. Okay, now let's go to the multiple regression. Multiple regression. Multiple regression, we are going to use a command for it. And the command we are going to use for the multiple regression, you should work along with me, is genmulti. Genmulti. So genmulti, that's the name I'm calling it, just to indicate that it's a multiple regression. So genmulti equal to, then we are going to type all the independent variables. All of them. What is the first one? Well, first you need to indicate the linear model. You need to indicate the linear model. The linear model is LM. So you write LM indicating the linear model, bring a bracket, and type the dependent variable, which is your K, with your tilde symbol. Then your price in capital, your complement price in capital C. Okay. Your income, then you do plus M. Okay. Now, location is lock. Depending on which, go and check the names that you have in the Excel and use exact names there. So it is lock. Okay. If you don't take it, you can we'll go and make it locate. So check the actual name plus occupation, OCC, plus religion, REL. So just as it is in the data set. So let me check. Okay, you got to check your data set and see whether those were the names you use. When I check my data set, those were the exact names used. So if the data set has a capital, you have to make it capital here. If it does not have a capital, you don't need to make it capital. After religion, then you bring a comma, then the name of the data set. So you type data and then add gen. Okay. So this is going to give you the multiple regression, but I want to get the results quickly. So step out of the bracket and then type summary into bracket, the name you gave to the equation, genmulti. Genmulti. And that's it. Okay. Once you've done that, please remember there must be a semicolon. After you step out of the bracket, there must be a semicolon. Okay. There must be a semicolon. And once you are done with all of this, you run, you click run, or you do Control Enter. You will see the beautiful results showing down there. Look down there is a summary of the entire results. Okay. It's a summary of the entire results. So look at the entire results. Okay. This is not too different from the one we did in Excel, but this one gives us more information. And I'll show you where. If you look at the stars will tell you the exact significant values of the independent variables. So if you look at the price, it's a dot. And anytime it's a dot, it means that it is significant at 10%. The interpretation is down there. If it is 2-star, as you can see it here, 2-star means it's significant at 1%. 3-star means it's significant at 0.1%. 1-star means it's significant at 5%. Regarding the interpretation of the multiple R-square, we have done that already. The adjusted R-square, we've done that. The p-value for the F statistic, we did that the last time. And when it is actually 0, it means that all the variables are jointly significant in influencing the dependent variable. Now, so the most important thing are the p-values of the independent variables and whether they are significant or not. And you can see that all the categorical variables, the dummy variables are significant, except location urban. Except location urban. Any question on this before we move on? Okay. Now, another thing you can do is to determine the confidence interval. Okay. You can ask R to tell you the confidence interval for each of the individuals. Sometimes you don't want the p-values, you want the confidence interval. So how do you command that? Let's go to our commands. Just type the word round. Okay. Round into brackets, conf. And it will come, it will show conf, okay, int. You see that it has come conf int or conf int. Okay. So once it shows that, it will give you a bracket, which means you have to indicate the name. And our name is Gen multi. So you type the name of the equation, which is Gen multi. Then you step out of the bracket, bring a comma, and then indicate how many decimals. That's a rounding. So I want to type the decimals to be 2. So how many confidence interval? And this confidence interval uses something that is known as the profile log likelihood. And it is correct to 2 decimal places. That's why you have 2 there. So once you run this, which I'm going to do, the results will show down there in the console. You can see that it gives you the upper bound of the confidence interval and then the lower bound of the confidence interval. Now, what is the essence of confidence interval here? Well, the essence is that if you check the coefficient, the estimate, which is in the column here. So if you look at the column here, I just want to show you something. So if you look at the estimate column there, okay, the idea of the confidence interval is that the independent variable, the particular independent variable is significant if it is within the confidence interval. Okay, if it is within. So if you take price, the value of price is what? Is negative 0.315. Okay, that's the value of price, negative 0.315. Now let's go and see whether it is within the confidence interval. Yes, when you look at the confidence interval, okay, carefully, you will notice that the interval is negative, that's the interval. Okay, it is negative 6.35 and then 0.04. So that value of negative 3.35, it's within the confidence interval. It falls within the confidence interval. So it is another way of saying that that variable is statistically significant. That's it. Okay. So that is how you're able to tell whether a particular variable is confidently, you can rely on it. That is it. Either you use a p-value or you use a confidence interval. So that is another way of showing your results. Okay. Now, there's another thing you can determine in the results. And what is that? Well, when you look at the results, in fact, I should have done the simple regression one for you to see. Okay. Remember that the simple regression one was gene simple, and this one is gene multi. Okay. So let me share something with you, something quite interesting. Gene simple and then gene multi. Now, you remember that one of the rules of regression is that the error term, the expected value of the error term must be 0. Please, I'm going to run my gene simple. I think I've run it already. Let me see, scroll up, and then I haven't run the gene simple. Let me run it. Okay, so this is my gene simple, which had the only price. Okay, that's the value. I ran this command and I got the results here. Okay. Now, when you look at the gene simple, you can decide to indicate the residual. You want to check the expected value of the error term. And one of the rules is that it must be normally distributed with a 0 mean and with a constant variance. So you would type the word residual. So type residual. And again, I can use a gene multitude. Type residual into brackets, residual into brackets, then gene simple. That's the name of your simple data set. So, ladies and gentlemen, what I'm trying to do here is I'm trying to find whether the residuals actually make up 0. Please note, the residuals is made up of two things. The actual dependent variable, okay, minus a predicted dependent variable. Let me write that down for you. It's very important you understand it. Okay. Okay. So I hope this thing doesn't freeze. I hope it does not freeze. Oh, come on. Okay. So the residuals, which is the U cap I, it is the actual value of the dependent variable minus the predicted value of the dependent variable. Okay, the predicted value of the dependent variable. That is a residual. Okay, and so we are going to check the residual, and then we check it against the predicted. Okay, and then we see whether it, and again, if you remember a simple regression, regression is equal to, simple regression is alpha plus beta x plus the error term. Okay, this is how it is. And so if you want the error term, okay, if you want just this one, you move everything to the right-hand side. So you will have y, which is the actual minus the predicted. Like we call it, something like y hat. Okay. And this y hat is actually the left part here. Okay, this part here. So this y minus the y cap will give you what? The u. Okay, that is why we say that the error term is the actual, which is this, minus the predicted, which is that. So what we are going to do is to check whether that is true. Okay. So we go to our R, and then we run the command with residual gene simple. I just ran it. So let me look down. So you can see that it is going to give you each one of them. It will give you for each of the 40 observations, okay, the value of the actual minus the residual. The value of the actual minus the residual. It will tell you each one of the value. Okay. Now, how do you get the fitted values, which is the predicted? Okay, the one I just did, which was y hat. How do you get that? Well, you can get that fitted value by typing fitted. Okay, fitted into brackets. Then you write the name of the equation, which is in this case Gen sample. And then you show it. So again, these are the fitted values. So do you see that you have the fitted values here? All right. And then you also have the actual. Okay. And so the residual becomes the actual minus the fitted. That's what it is, basically. The actual minus the fitted. Okay. Now, remember, what we are saying is that the expected value of this should be 0. That's what we are saying. The expected value of this should be 0. How can I? So you have to go and do for all of them. Remember, it's for all of them. Let me see what I can do something. Whether it works. I've not done that before. Okay, to see whether the expected value makes sense. Okay, so I've just created expected value down there, and you can see that it's not exactly 0. If you look down there, I just use the mean of the residual sample, and you can see that it is 5.38. It's a little bit not far from 0. Okay, so that means that the expected value of the error term is not fully 0, but it's not significantly different from 0 as well. So you can do a lot of residual analysis. When we come to residual analysis, in diagnostics, we shall do all of that. And once I've done for simple regression, that is the same thing you can do for multiple regression. So you can change everything and do it for the multiple regression. So what do I mean? You can go and copy this, everything I've done here, you can just copy it and then change the simple to multiple. So whatever is, you change the simple to multi. So wherever you see simple, change it to multi for the multiple run. I'm doing that, copy paste. Okay. And, you see my add, but the multiple regression is actually 0, eh? Look at it. So the residual for the multiple regression, these are the residuals, okay? And if you check carefully, most of them are around 1. Most of them are closer to 1 than the previous one. The fitted of the multiple regression one, the fitted, that is a predicted. When I run that, this is the value I get. Okay. And so the mean of the residual, okay, that's we are checking whether the expected value is 0. Let's run that for the multiple regression. Let's do that. And guess what? Negative 4.9708 e minus 1/5. That is the exponent of 17. So what it means is that there are 17 zeros before the 4. So you know what that means? What it means is that the expected value of the multiple regression, the expected value of the residual is actually 0. That is what it means. And you can see that down there in the console. So you should be able to run your own and be able to indicate whether or not it satisfies the assumption of, normality with a 0 mean and a constant variance. That's it. So you should learn how to showcase that it is 0 or it is not. Anyway, there are certain things you can do with R, which is also very nice. Okay, you can get the whole thing in a table, nice table for you. Okay, you can use several approaches to do that. You can do residual analysis. Residual analysis. I was just trying to do a couple of them. Okay, but you can do a lot of residual. You can plot the fitted versus the non-fitted and build some incredible, results. So I'm going to show you some of them because it's important, Now, to do that, there is a command that you need to, a package you need to install, and this package is known as JTools. JTools. So let's go and then install JTools. Click on install in the packages and type JTools. it will come. And then you can now install J-tools. After you've installed the J-tools, which I am installing, of course, your internet must be good before you actually do the installation. So you see, it is installing. If you have a very good and a fast internet, you are going to get a quick installation. I know most of you are all loaded, so you all have good internet. All right, so J-tools is installed. So the next thing you want to do is to type library into brackets J-tools. Okay. Library into bracket J-tools to just invoke it. Okay, so the first thing you have to do in an instructional way, install and invoke J-tools. Now, why are we doing J-tools? We are doing J-tools because J-tools can give us very beautiful graphs. Very beautiful graph. Okay, now that you've done J-tools, let us do a different kind of writing the regression and then see how the results look like. So type gen multi equal to the same LM with your bracket, the Q, the tilde sign, P plus C plus M plus locate, look plus oc, occupation, plus rel for religion. Then you do comma after all of that. Then you indicate data equal to gen. Then you step out of the bracket. This is something we've already done. Instead of typing summary gen multi, this time you do sum, S-U-M-M. Sum into bracket, the name of the equation, gen multi. Watch how the results is beautiful and different from the previous one because of J-tools that you have run. When you do that, you're going to get these beautiful results here. Look at it. If this is not beautiful, then I don't know what else is beautiful. It tells you the number of observations. It tells you which is the dependent variable. It tells you the type of regression, which is OLS regression. And then it gives you the p-value for the fitness of the model. The most important things, it tells you, this is what you bring in a journal article when you actually write. Okay, the fitness of the model, the F-test, the p-value of the F-test is 0, which means the variables are generally significant. The R-square is 99, which means 99% of the variability in the regression model is explained by all the independent variables. The adjusted R-square equals R-square, which means that the models are relevant. Then the estimate, each of the estimates, the p-values are clearly shown. Whether they are significant or not, it will depend on whether it is within, whether it is, what do you call it? Whether it is below 5% or above 5%. So that's another way. J-tools help you to beautifully organize your data set like that. Now, regarding the details, I've already gone through it with you. Okay. Now, you can also generate the confidence interval. Okay. You can remove the p-values and rather replace it with a confidence interval if you want. Okay. Yeah, it's not too important, to be honest with you, but you can do that. It's in the slide, so you can check it out, do it. You can also check the predicted values. And you can also, what do you call it? Remove the intercept. I've told you how to remove the intercept. When you are writing, after, what do you call it? Before the P, you bring 0 plus the P. Before the P, you bring 0 plus the P, and that will remove the intercept so that the intercept is not there. If I go and do 0 plus P right now, watch it. I'm going to do that right now. 0 plus P. And if you run it, I just did, you can see that the intercept is vanished. The intercept is gone. You can see that the R-square is 100% now. The intercept is gone. So that is one way you can reduce the intercept. It helps you to reduce the intercept. Okay, so that is it. That is how you analyze building different regression. But like I said, sometimes you read people's papers, and when you read the papers, you feel like, there are so many models. The author has this model, 1 model, 2 model, 3. What is that? There are multiple types of robust standard errors that you can use. Ladies and gentlemen, please follow me. Follow me. Look at the last column here, the middle column. You have the estimate. Okay? And the last time I told you that the estimate divided by the standard error is equal to the t statistic. And when the t statistic is read on the table, that's when you get a p-value. The estimate divided by the standard error equals a t statistic. So if the standard errors are quite large, then you're going to get what? Because remember, the standard error is a denominator. The estimate is rather the numerator. So if the standard error is too big, the whole t statistic will be smaller. And when the t statistic is smaller, what it means is that your p-value will be bigger. And when your p-value is bigger, that's not good news. Okay, that means that you're going to get independent, what do you call it? You're going to get some issues related to your work. So what we can do here, and what we are going to do here, is we are going to look at the multiple types of robust standard errors. And I'm saying that the standard errors, when it is too big, that's not good news. So you want the standard error to be smaller. When the standard error is smaller, the independent variable becomes much more significant. Okay. Now, how do you make it standard? Well, it's not because of that you force it, but it has to be robust. So there are certain robust standard errors that can be used. And that is one way to differentiate your original model from the robust standard error model. So you can have 2 models like this. I'll show you very soon. Oops. The thing is not showing. Oops. Oh, that thing is gone. This is not good. This thing will be restarted. How do you do that? You can do that by using robust standard errors. So there are 5 main different robust standard errors, and I wanted to write them, but the thing is not allowing me to write them for you. Oh. Is my screen black? Okay, I think it's showing now. Okay, so there's a standard error, robust standard error, which is H1. There is another robust standard error, which is H2. Okay. There's another robust standard error, which is H3. You have H4, robust standard error. You have H5, robust standard error. All of this can be indicated. And then once you've done with that, you can now have model 1. Okay, where model 1 deals with the robust standard error 1. Model 2 with the data set will deal with robust standard 2. And then on and on and on and on. So that's what I'm going to do with one of them. And then you put it in a beautiful table, so that you can appreciate what it is. So if you have a package, okay, there's a package called sandwich package. Okay, if you have, and normally it is already implanted in R. The default robust standard error, it is HC3. Did I say HO? It's HC. Okay. You get if you set the word robust to true. In Stata, and later on you will learn in Stata, the default is HC1. HC1. Okay. But this one, it is not. So there are different robust standard errors you can do. But what I'm about to do, and I will treat the robust standard errors later. Okay. But what I want to do now is to add another model to the existing model, just to show you the beauty of the table analysis, because you guys need to know this. So that when you are submitting your work, you know the tabular analysis. So let's run this model using generalized lists, a generalized linear model. So I'm going to run the model using generalized linear model. So I just want to type it as gen multi, okay, GLM. So I'm calling it gen multi GLM to indicate generalized linear model. And then you make it equal to GLM. That is it. So it doesn't use LM, linear model, but it uses a generalized linear model. So you type that, and then you type your dependent variable plus the others, price times complement price times income plus location plus occupation plus religion, comma, data being equal to gen. You know this already. And then after that, you would step out of the bracket, and then you will use sum, S-U-M-M into brackets, the gen multi, then the GLM, gen multi GLM. So this will create a robust, a generalized linear model for you. Let's run that and see. Look down there. So you can see the generalized linear model. That is how it is. I can see without a shadow of a doubt that it's not significantly different from the OLS regression. There are some beautiful information there. The dependent variable is also still Q. You can see that the type of regression is linear regression. If you can remember, the previous one, it was OLS regression. So that was specific. This is general. And then this one, it gives you the F statistic. The p-value is still 0. The pseudo R-square, which is Krag-Ola pseudo, there are two kinds of R-square, okay? And the pseudo R-square, the Krag-Ola is always the best to go for. The generalized linear model also gives you the archaic information, the AIC and the BIC. We'll talk about these things later. But what it's doing is that it does not use OLS. It uses maximum likelihood estimation for the standard error. So you can see they've written MLE, which is the maximum likelihood estimation. Your most important thing you're looking for are the estimates as well as the p-value. So that's another model I've run, okay, which is called generalized linear model. Okay. Now I'm going to export all the models into a beautiful table. But there's one more model I want to bring. Okay. There's one more model that I feel like I should introduce. Okay. Let's call it robust standard error model. Okay. So I'm just going to take the original one, the normal linear model. The normal linear model. I'm going to rename it. You can rename it. So gen multi R, or let's call it gen multi robust. Gen multi robust equal to hold on, equal to normally before you can do some of these things, RLN. Okay, I hope that works. Robust linear model, RLN. Okay, RLM. But let me see whether that'll work. Okay. Let me see whether that'll work. RLM, just watch my screen. I'm just adding, these are models I will explain later, but I just want to show you the beauty of the data. Let me see whether that'll work. RLM. Okay, so that didn't work. This is not surprising, partly because you have to install a package. Okay, you have to install a package. The packages, the packages are too many. Okay, so let's install a package called foreign. I think we have it. Library into bracket foreign. Okay, and then another package called library into bracket mass. Library into bracket foreign, library into bracket mass. These are just packages to help you run this thing. Okay, I don't know whether I have them. So let me search for them on the search section. Foreign. I think I have foreign, so foreign is sorted. Okay. What about mass? Type mass. Type mass. Come on, mass is there, so fantastic. I can do that. So I've indicated both of them. Now let me run my robust. Let's see. Okay, so the summary must be full word. Okay. The summary must be full word. So SUMMRY. Let's see. Ah, there you go. So it has come. So you can see the robust LM. Yeah, this is just interesting and crazily interesting. So you can see that the estimates have changed. Okay, some of the estimates have changed, and the p-values, the t-values are all bigger. Okay, the t-values are all bigger. So I'm just trying to show you some different models you can run. At this stage, we're going to put all of them into a table, which is where my interest is. We're going to put everything into a beautiful, 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 beautiful table. Beautiful table. Whether you like it or not, you're going to have some beautiful tables. Okay. So that's what I want to do. Just want to show you those beautiful tables. Where is that? Oh, come on. What's the name? I am looking for the beautiful tables. Oh. That's frozen. Please give me some time. Okay. Just give me some few minutes to get back to, wow. This thing has gone so down. Okay. All right, so let me take this thing off. So we're going to do something called hacks table. Okay. Watch what I'm doing. I'm looking for a command called hacks table. If you have not installed it, it's not the hacks table. Hacks. Okay, I don't have it. So install hacks table. Some of these command installation are just one time, but if you don't have it, you don't have it. Hacks table, HUX table. HUX table. That's it. HUX table. It's going to put all these three models I've done in a beautiful, beautiful way. So let's install HUX table and then type the library command name HUX table into brackets. Sorry, library into bracket HUX table. Library into bracket HUX table. Remember, your system must be running. Library into bracket HUX table. And again, don't worry, so just understand what I'm doing. Even if you can't do it, just understand what I'm doing and then do it later. Okay? Because if the internet is not good, you'll be struggling and it is no fault of yours. So let's run the command known as HUX table. HUX table. You see, I made a mistake. Instead of HUX, I made HUX. Okay, let's run that again. All right, so HUX table has been run. Now I'm going to put everything into a beautiful data, a beautiful table for you to see how the whole thing works. So the first thing I'm going to do is type the command export. Export the results underscore sums into brackets. Let's show the gene multi first. So type gene multi. Then you do comma. The next thing that we ran was gene multi GLM. I remember. We run gene multi GLM. That is here. Then we also run gene multi robust. In fact, we even had the original gene sample. So let me see what that gene sample works. I don't think we did sums for it today. Okay. And then let's indicate that the scale should be true. So you indicate that scale is true. And then we are going to see, maybe it will work, maybe it doesn't work, but I'm going to just fidget with a 4. If the 4 don't work, I'll just remove some from it. All right, so just as I thought, not all of them will work because the robust, I didn't use the sum command. Okay. So I'll remove the robust and see. I just want to see how the tables look like. Okay, now you go, see the beautiful table that I'm talking about. And this table is nicely organized, so you can send it to, your journal paper. Oops. What is the results? The internet is just misbehaving. All right, so let me just make this thing bigger so that you can see. So you can see from this table that you have model 1, it has automatically organized it for you. You have model 1, and model 1 is a gene multi, that is up here. You have model 2, which is a gene multi GLM, and then the gene simple. Remember, the gene simple is a simple regression. And so you can see that that model 3, only price was shown there. Okay. And then it automatically puts the standard errors in a bracket. Okay. And then it gives you for each, you see, the most important thing, like I told you, are the coefficients. And then the standard error. And then whether it is significant or not. So the stars are there to tell you whether it's significant or it's not significant. Okay. And you can see at the bottom, the sample size is there showing. The R square is there showing. Okay. The R square is there. And then some other information are there for you to be able to work on. And then beautiful interpretations are given for this. So what caused this table to be generated was because of our hacks table. Okay, our hacks table was able to help us to be able to export everything. Only for those that use the sums, okay, the summary or the sums command. It's not for those that use the summary, but it's for those that use the sums. Sorry, the SUMM. And that one gives you a beautiful table like what you see here. All right. So, ladies and gentlemen, now at this stage, everything that you need to know about this thing, you already know. First thing I want you to note is that note whether the individual variables are significant. Individual significant, note that. We've done that last time. 2, note the joint significance using the F test and the p-value for the F test. Note that. 3, note how to interpret the coefficient. And at this stage, I'm going to interpret the coefficient of 2 of them for you. Okay, one is a numerical variable, the other is a dummy variable. I'm going to show you how you do the interpretation, because if you don't know how to interpret the coefficient, it can hurt you. But the way some people interpret it is also bad. So I'm going to show you, because the way you interpret a numerical variable is different from the way you interpret a categorical variable. So I'm going to interpret the coefficient of price for you. Okay. The coefficient of price here is negative 5.7. Okay, I'm just picking it from here. Okay. Just what is shown here. How do you interpret this? I'm going to say it. You might want to put some things down for us. We start with the word on average, because regression is an average thing. It's a measure of central tendency. So you say that on average, given, sometimes the temptation will be the holding all other factors constant. But I want you guys to know those factors. So for your beginner's interpretation, I want you to mention the factors instead of saying holding all other factors constant. Okay. So on average, given the price of gin, sorry, because you are interpreting the price of gin, you will not make it given. So every other thing can be given, but except the price of gin. So all those that are going to be given are these things. But watch how I mention the dummy variables. Watch how I mention them. On average, given the price of gin, why am I mentioning the price of gin again? Okay. All right, let me start again. On average, given the complement price of gin, the income of the people, given the complement price of gin, that is a C, the income of the people, the location of the shop, okay, the location of the shop, the occupation and religion of the people, the occupation and the religion of the people, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin reduces the quantity demanded of gin by 5.7 units. A 1 unit increase in the price of gin decreases the quantity demanded of gin by 5.7 units. So you can see that I said a 1 unit increase in the price of gin, the independent variable, the predictor. When it changes by 1 unit, but you don't use change, you can use a decrease or increase. When it increases, in this case, by 1 unit, the quantity demanded of gin will fall. Why fall? Fall because the value of 5.7 is negative. It will fall by 5.7 units. Now, remember, I didn't say a 1% change increase in price. I didn't say that a $1 increase in price. I didn't say a 1 CD increase. I just used the word unit. When you do the word unit, you prevent yourself from getting worried with a unit of measurement. So I said a 1 unit increase in the price of gin reduces the quantity demanded of gin by the estimate. Okay. Now remember, price is a numerical variable, so it changes. It increases and it falls. That is why we say a 1 unit increase, a 1 unit increase, a 1 unit increase. But when it comes to location, location doesn't increase and fall. Religion doesn't increase and fall. Occupation doesn't increase and fall. These are dummy variables. So the way you interpret these dummy variables is different from the way you interpret. So in this case of price, after you've interpreted it, then you say that, and this increase is significant at 10%. Because when we saw it earlier, you said it. You said that it is significant at 10%. So you say that this increase is significant at 10%. Now let me interpret religion Muslim. I'm just using one of them for one of the dummy variables, religion Muslim. And remember that for the religion Muslim, okay, in case you don't know, the religion Muslim, there was a reference category, which was Buddhist. Okay, there's a reference category called Buddhist, which is not shown here actually. But I'm going to interpret this religion Muslim. Watch the value. The value is negative 23.01. So we start by saying on average, given the price and complement price of gin, and I'm talking about these so that, see, you got to mention everything except the religion here. On average, given the price and complement price of gin, the location of the shop, and the occupation of the people. You see, I never mentioned any religion. And the occupation of the people, quantity demanded is predicted to be. Quantity demanded is expected to be 23.01 units less. Quantity demanded is predicted or expected to be 23.01 units less if the people are Muslims. If the people are Muslims, then Buddhists. You see, Buddhist is not here. And so the fact that Buddhist is not here should tell you that it is a reference category. So it means that anytime you mention Muslims, you're talking about Muslims in relation to what? Buddhists. So quantity demanded is predicted. I didn't say that a one unit increase in the price of religion. No, religion doesn't increase or fall. So watch the language. Quantity demanded is expected to be 23.01 units less. Why less? Because the value was negative. It's predicted to 23.01 units less if the people are Muslims than Buddhists. Buddhist is a reference category than Buddhists. Kofi?
You have it.
Kofi, ask your question.
Okay. Good afternoon. Please, I just wanted to ask, in the case of location, I think we have rural and urban, and one of them is supposed to be the reference category. On my PC, I had only location urban, but I noticed in your...
Yeah. Don't worry, it's because we are using the Hacks table for this.
Okay.
Yeah, it won't change. So when you are actually talking, you will use the original one that you know.
Okay, thank you.
So guys, that's how you interpret. Go and learn how to interpret all the others. I've just shown you how to interpret a numerical variable and a categorical variable. Learn and note that the categorical variables don't rise and fall. Okay, they are there, they don't change. And they being there is either you are there or you are not there. Their presence will make the dependent variable be different in value, predictably, different in value. Okay, it doesn't increase or decrease. It is just different. Gogobi, your question.
All right, Doc. So when you're interpreting, you said something like for beginners, we can mention all the variables, even though we can say holding all factors constant. My question is, where does our beginner start end? Is it for exams that when we finish, we can do holding all other factors, or if assignment, we can still do holding all factors constant?
Okay, so as far as you are with me, you will not hold all other factors constant. After this year, when you go to your second year and you are writing your thesis, then you can hold other factors. But for this course, okay, mention the factors.
Okay, all right.
Yes. Yeah, it's very important so that at least you know what is changing. Because some people mention holding other factors constant, when in fact, if they were to be mentioning it, they would have even mentioned the variable that is going to even change. They would have still mentioned the price. So if price is the one they are interpreting, they would have said holding all other factors constant. But if they were to be mentioning, they would have mentioned price too, which means the price wasn't held constant. So the knowledge of it is what I'm training you guys. Know that the variable in question is not held constant. But after this year, you can hold the other factors constant.
All right, thanks.
All right. And one thing is that when you have mentioned interpreted the whole thing, you should add that, and this variable is significant at, and I'm talking about for purpose of journals and theses. It's okay. So a 1 unit increase in blah 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 will lead to a 14% fall in days, and this fall is statistically significant at 1%. So you got to mention that, and then indicate the percentage of significance. All right, ladies and gentlemen, interpretation is very important. I won't lie to you. I've rejected some papers before that didn't do proper interpretation. Interpretation is critical. And in your assignment, you do a lot of interpretations. So it is important that you know how to do interpretation. All right. So check the slides. Yeah, Francis, your hand is up again.
All right, so another question. So once you mention assignments, we do interpretation. So supposing you've given us some variables to interpret and it wasn't significant, yet you've asked us to interpret. Can I choose not to interpret since it's not significant?
Oh, I will first of all, if it is significant, if it is insignificant, you should still interpret. You are not interpreting it because it is significant. You are interpreting it because you have to interpret it. You have been asked by me to interpret it. Even if it's insignificant, you should still say that, however, the variable is insignificant. Oh, by the way, don't confuse the two. I spoke about indicating whether it's significant or insignificant only when you are writing your thesis or a paper. But for your assignment, if I tell you to interpret, I'm not expecting you to add that it is significant or insignificant, because I would have asked you that question already.
All right.
Okay, so guys know how to interpret the variables a lot, those variables. Let's go to one important thing that students miss, and that is specifying the regression model. Specifying the regression model, and then specifying the regression model, and then, what do you call it? Writing this regression equation. Okay. Either you are specifying the model or you are writing the regression equation. What is the difference in the two? Specifying the model and writing the equation. Now, I must say that anytime you're going to do any regression, you have to specify the regression model. Specific, not the general one. The general one, I've given it to you already. Okay. And the way you specify the model has to do with the way you decide to use. So let me give you an example. All right. So watch this. Okay. Now, the quantity demanded, I can say that let K be the quantity demanded. Okay. We are going to specify the regression model. And it is always nice that the way the model looks like in your Excel or in your R, that is how you should specify it. However, you can use some words to specify it, okay, and then interpret them. For example, I'm using Q here, and then you can come down and say where Q equals to quantity demanded, okay, blah, 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 blah. Somebody will just use the whole quantity and rather say that quantity, okay, equal to beta naught and blah, 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 blah. Okay. But for this very course, the ones, how you see the thing in the regression model, that is how you want to specify the model. Okay. How you see the thing in the model, that's how you want to specify. So how are they reflected in the model? Let's go back to the model. Okay. And again, coming back to one of you, your question, don't use this very model. Okay. Don't use this very, that rural shouldn't have come in this very model. Rural shouldn't have come. That is why in model 2, watch it. That is why in model 2, rural was not even shown. Rural was not shown. So use the model 2 and to specify the model. And I'm going to use that. So how do you specify the model? Specifying the model means you are bringing letters, no numbers. You're just bringing letters and no numbers. Oops, the thing is not showing now. It's not showing. Let me just go back. You must master how to do something. Let me see what I can do with even here on top of it. So if you are specifying the model, this is how you write it. Okay. Uh-oh. Okay. So you write Q. Looks like it's still not showing.